Hello everyone. Today I'm going to talk about my project, which is machine learning and linear algebra. My name is Tuncer Schmidt and I'm studying computer science. As a summary, I'm going to talk about tensors, NumPy library, linear regression, and activation functions. And I'm going to talk about application of linear regression. As an introduction, in computer science, everything related to life needs to be converted into the programming world. However, sometimes it's not easy. There needs to be logic behind it. So easiest way to get this logic is using math. So especially linear algebra, machine learning and artificial intelligence need linear algebra to detect pictures, give precise numbers, or give a probability numbers. We can use linear algebra for getting correct prices for our cars, houses, cell phones. In many cases, linear algebra is the one way to solve our problems. Tensors. Tensor is an array of numbers arranged on a regular grid with variable number of axes. Basically, tensors is the general form of matrices. NumPy. NumPy is an essential Python library to perform mathematical and scientific computations. Basically, we cannot use matrices directly in our coding in computer science. So some people, they wrote some functions to help us to calculate these matrices directly. Basically, you are filling the gaps by using the NumPy library, or you are reading a file directly. So it helps us to make the matrix calculations. It can be addition, subtraction, multiplication, transpose, or whatever you say. Linear regression. Linear regression is a method for modeling the relationship between two scalar values. Please don't restrain yourself with the two values. It can be more than that. The input variable x and the output variable y. The model assumes that y is a linear function or weighted sum of the input variable. Linear regression can be formed in matrix form. Here is the formula. We can see y is the output value, xb is like the x, like b is like the slope, x is the x values, is the additional number. It is the same formula we are for creating a line in the coordinate system. Actually, we know it. We most of the time we know this formula, like y equals mx plus n. Here xb equals like this one, but basically they made a multiplication here and they wrote in another form. And on the right side, it shows us that basically it shows us the linear combination that we learned. We are making a matrix multiplication and we are adding all of them and it's giving us the values. Artificial neural network. Artificial neural network is an attempt to simulate the network of neurons that make up a human brain so that the computer will be able to learn things and make decisions in a human-like manner. Basically, we are trying to create the same thing that we are having in our mind. But the computer, they don't understand in the same way we are understanding. If you look at the right side of the screen, like the photos, there is a text. But however, like the PC, they don't, it does not understand like we see. It sees numbers, or like we are like looking at the X-ray. Like a computer cannot understand color. Like because of that, we are using RGB values. RGB values is like three different numbers corresponding to some certain colors. For example, if you say 000, it means white. If you say like 255, 255 and 255, it means black. Or there's a heartbeat, and basically everything we have in our life, we can turn them into matrices to use them and give the machine the proper value and understanding. And here on the right, in the middle, it shows like blue values. Blue values actually are values that we are putting inside. Here, like there are orange circles. Orange circles means loss function and activation function. Basically, we are using these functions to train our model and get the correct value. And here we have like 3 blue and 4 like circles. In real world, it's not like that. It can be like 500 different like circles like under each other. Activation functions. Activation functions is the function in artificial neuron that delivers an output based on inputs. Here, there are some example of it. If you look at the screen, you can see like sigmoid, tangent, ReLU, and other ones. We are not going to use this stuff in linear regression because these functions, they are not linearly increasing or decreasing. They are not linear. I am talking about this stuff because I explained the neural network, so I need to explain the activation functions. Basically, sigmoid is used like for if you have like two different values. For example, you have like many different photos. You have cat and dog. You want to decide this is cat or dog, because like this sigmoid function is giving you value between 0 and 1. If it is 1, it can be dog. If it is 0, it can be cat. For tangent value, it can be 1, 0, and -1. So you can have three different values. For ReLU, if it is minus, it makes it 0. If it is positive, it uses the number directly. So you can have many different values. For example, you have 10 different car models. You can use ReLU for that. So it's going to give you better results, better correct results. Introduction. So whatever we do, like in life, is like finding solution for our problems. For here, we are using linear algebra for finding the correct pricing for car, houses, apartments, or detecting similar photos, or like detecting like the signature is like real or fake, or the check is real or fake, or written statement is include some embedded words or not. Solving by linear regression application. If you look at the photo, we see a line here. So it's increasing linearly and or decreasing linearly. The colors you see, it's showing the errors. So down here, we have a formula. It's like b0 plus x multiplied b equals y. It is the same formula for this line. But in math, most of the time, we see it like y equals mx plus n. Here, it shows that if you get the number x values, and if you put 1 in front of them and then make them a matrix, and if you multiply with the b0 and b1 values, you are going to get the output. Here, it is the same thing, just like they multiplied this one. So it is another form of it. And it gives us the least square matrix. And here it shows the same thing. And it says that after this one, you have to multiply these values by the transpose. So if you multiply them with the transpose, they need to be same. It's the same thing here actually. Like if you x multiplied b should be equal to y, and even if you multiply with the transpose of x to each side, it should be the same thing because basic like multiplication. At the end, it says that the value you get after this multiplication is going to give you the value like b0 and b1. For example, if you look at the real values, I mean, we have 4 data points. In real life, we have more than that. So we have like points, this one. And if you look at the x values, it's like 1, 2, 3, 4. It's here. Y values, 1, 3, 3, 5. Yes, it's here. So we wrote the numbers here and we put the ones in front of them and multiply b0 and b1, and this is the value. And we know these values, and this is the transpose of x, and the y values is the output. So we are multiplying x with the transpose. So it's giving us a number. Here we are multiplying y with the x transpose. It's giving another number. And we know that they need to be equal. So if we multiply them like that, they needs to be equal. So we are putting the numbers in the correct place, and it's giving the output. From here, we are finding that b0 is 0 and b1 is 1.2. Basically, it's giving us the best line of y. So this is the function for y. So what does it tell us? Basically, it tells us that this is the best line on your graphic And if you get a number or point or data, whatever you say, if this data is closest to this line, it means you are on the right track. If it is farther than this line, it means there's something wrong. Something wrong is happening. So you need to check your data. Conclusion. Linear regression is just one of the many uses of linear algebra. There are many different fields that can be applied. It's very useful in many disciplines, especially computer science. It's a math concept and gives meaning to the values, and it's so important and crucial. Basically, linear algebra is everywhere in our life. And these are the references. If you want, you can take a look at it. Lastly, I want to say one thing. Please don't get confused only. Don't limit yourself with one thing. Linear regression, it's not only a function. It can be everything. It can be house prices. It can be car prices. It can be like cooking. Even cooking is a linear regression. Or like the driverless car, autonomous car. They are like linear regression. Linear regression is everywhere in our life. Thank you so much.